Thank you. It's great to be here. I'm going to dive right in and tell you a little bit about what we're doing at Theon to help all of you realize your vision for neurotechnology. So we're all here because I think we recognize that we're at an exciting time where there's a huge potential for neurotechnology. I'm a computational neuroscientist by training, so I'm very excited about where we are now in the field, where we're seeing a lot of possible applications of neuroscience, biosensor, data analysis, and applications that can be truly impactful and transformative in many people's lives. And so some examples of that include developing new kinds of cognitive or health biomarkers, perhaps using things like advanced brain network analysis or monitoring brain activity at the level of the cortex. Developing enhanced human and AI interaction capabilities and optimizing performance. So for instance, here's an example of a person operating a brain-computer interface. This is actually our Chief Technology Officer, Christian Kothe, and we're decoding in real time whether he's making a mistake. The computer can detect that faster than his brain can actually detect it and respond to correct the error. Down here we have an example where an individual is in a driving simulator and we're tracking whether the person's mind wandering and using that to provide auditory feedback to help keep the person engaged in the task, but also potentially in the future to tell an autonomous monitoring system inside the vehicle to say, hey, maybe I should take over from the driver because the driver is not capable of monitoring the road right now. Other examples include quantified self and personalized tracking. Here's an example where you might have a affect and a affective monitoring system that's monitoring valence and arousal on your mobile device, and you could see how your emotion states change over the day or even see your brain activity in real time. Cognitive restoration enhancement, I'm very excited about this area. This is an example of a closed loop system where this individual is wearing an EEG headset, also monitoring his ECG, heart rate, his muscle activity, and he can engage with this augmented reality experience where as he activates or increases activity in certain parts of his brain, in this case the dorsolateral prefrontal cortex, and suppresses activity in other areas of the brain, he can control these orbs. The idea is he's getting a reward feedback from this experience that will eventually, we believe, modify brain networks and brain structures to perhaps produce a more desirable state for the brain. Also, it's just kind of cool and fun that you can make orbs levitate over the La Jolla coastline in augmented reality. Someday that will be real, hovering orbs. Another example, new kinds of entertainment and experiences in art. So for instance, here's two people engaged in an experience here where as their brain activity gets into sync with each other, they can engage an artificial life world in virtual reality, and it's an experience where they have to basically get into the same neural state in order to sort of unlock certain achievements in the game world. Finally, intelligent, connected environments. The Internet of Things is expanding. There are more and more things out there. Also, there's people, we're getting connected to each other. What happens when we connect our brains through the cloud to the devices around us? And we can have things like, for instance, here, an individual who is, as this person is relaxing, and let me just play that again. As this person is relaxing, it's modifying the lighting in the environment to reflect the person's state. And all of these examples require, however, further scientific discovery and new insights to really help us realize the potential for these new ways of looking at the brain and at the body. And we need new kinds of real-world translational solutions to help take this technology out of the laboratory environments and out into the real world where it can have real impact. So that's what we are working on at Theon. And our goal is to help accelerate and catalyze and power a new, what we see as a revolution, really, in neurotechnology, both on the research side as well as on the application side, and to apply these kinds of advancements in neurotechnology to everyday life. And our goal is that, what we hope is that by providing turnkey access to advanced state-of-the-art pipelines for brain-computer interfacing and biosignal processing and analysis, we can help to both power that research and also allow for new kinds of applications to emerge, where we can integrate the capabilities of these pipelines into any application or device anytime or anywhere. And essentially, in a word, what we're trying to do is make really hard stuff easier. So you don't have to reinvent the wheel. It can take years to do the research and development required to, say, build your own brain-computer interface pipeline and assemble a team to do all that and a bunch of neuroscientists. What we want to do is make it possible for you to have that capability at your fingertips to deploy, say, a brain-computer interface pipeline within a weekend. So some of the typical kinds of analyses that people might perform are things like data pre-processing and cleaning, and data quality assessment, and neural and physiological feature extraction and analysis, event-related potential analysis, spectral analysis, brain mapping connectivity. These are all examples of things that many, many people are doing, and they're actually doing it in many cases in relatively similar ways. So we know a lot about how to do this right now in ways that get you the kind of result that you would like. Testing your own statistical hypotheses, and data classification and BCI models, and also exploratory data analysis, just looking into your data to see what's there, what patterns are there when you're conducting an experiment and testing that in your populations. So our goal is really to allow you to have access to capabilities that allow those kinds of typical analyses, to have those capabilities at your fingertips. Some of the open research software and standards that we developed back in the past, we were involved in the EEG Lab project. Many different technologies around EEG Lab, including BCI Lab, an advanced brain-computer interface software package, lab streaming layer for synchronizing your data from heart rate sensors and brain sensors, SIF for modeling brain activity and brain dynamics and networks at the level of sources, and some neuroinformatics tools like HEAD and S and Cascade. What we're doing now is we've developed at Theon what's called the Neuroscale ecosystem. And what Neuroscale allows you to do, it's really meant to both serve researchers, but also really to serve application developers and people who are trying to get their fingers on the state-of-the-art in algorithms and signal processing and brain-machine interfacing and build applications on top of that. And so in a nutshell, what it allows you to do is take data, your biosensor data, upload or stream it to the cloud, and then apply advanced biosignal processing pipelines that either we provide to you or that you can even build yourself using the NeuroPipe suite, and then get your data back through our APIs, either streaming or in batch mode. And so like if you have a setup here where we've got EEG and heart rate monitoring and eye tracking and other biosensors, you'd stream them up through the gateway into Neuroscale, and then you've got all these algorithms that you can apply and pipelines, and you can store your data and do large-scale analysis on it and get back here, as I said, in real time, or even get back all your processed data and results and interactive reports that show you what's in your data and allow you to iterate. If you're, for instance, a researcher carrying out an experiment, you can iterate very, very quickly in doing hypothesis testing. Or if you're a developer, you can see immediately, is my device or my product having the effect that I want. So as I said, you can start with our pre-built pipelines, or you can build your own, and these are some of the kinds of things that people are generally interested in trying to measure, emotion and relaxation and other kinds of states. There's a lot of different data processing categories that you can choose and mix and match algorithms from to get the most out of your data and out of your pipelines. You can build your own pipelines using the NeuroPipe system, and I'll tell you a little bit about that in a second. This is just an example of using Neuroscale, where we're measuring brain activity from inside the ear as well as heart rate. I'm walking around kind of out in the woods, and here you can see in real time I'm seeing on my cell phone my heart rate and my brain activity, and also measures of my relaxation and other states that I can decode in the cloud from this biosensor that's very unobtrusive. You wouldn't even know that my brain was being monitored. We can actually connect this to things like we can ask Alexa, what's my relaxation level right now? And Alexa will respond. And so we've done that as well. And I can show you guys later if you're interested in playing around with that. I actually have a device with me. And so NeuroPipe, as I mentioned earlier, you can build your own pipelines as well. So NeuroPipe really is a way for you both to design pipelines using an interactive graphical user interface that you can drag and drop widgets and wire them together, but also to deploy those locally and test them and then run them on the cloud. So you can, as I said, design pipelines, deploy them to the cloud, and then get your access anytime or anywhere. This is just an example of building a real-time motor imagery BCI in 1 minute. I'll just show you very quickly how that would work. So here the person is clicking together a data input that's pulling data from an EEG sensor, putting a filter on that. For those of you who don't know this, don't worry about it. Time series plot, you can see your data in real time. I'm taking my filter data now and I'm chopping it up to pull out little segments of data. That person here is supposed to be imagining left and imagining right. So the data is now coming in for these little segments where they're imagining left and right into a classifier. And that classifier is now going out to stream my probabilities of left or right motor imagery out to a network. Now I'm pulling in some calibration data that I recorded where the person just imagined left and right a number of times. I'm just assigning some markers to it saying this type of signal means he imagined left and this type of signal meant that he was imagining right. Putting that into my data stream, wiring up my live stream again, and hitting go. And now the model calibrates itself, and now I've got the probabilities coming out of him imagining left and right. So you can now plug this into your quadcopter, and make your quadcopters start flying left and right based on you imagining left and right movement. So of course, that's an expert user. It might take you an hour or maybe 10 minutes to click that together, but the point is that you have that at your fingertips. So in my last 3 minutes, I'm going to tell you quickly about Neuroscale Insights, which is a service that we're launching on Neuroscale that's designed to really help you accelerate your research by allowing you to upload data and obtain, as I mentioned earlier, process results and reports back in an interpretable form that very quickly allow you to iterate in your hypothesis testing. And you can also design custom pipelines and put them up there too. And in the future, we'll be adding in the ability to share your data and workflows with other people and to issue search queries where you can search for troves of data that match certain characteristics and apply machine learning models or compare your data to it. For instance, saying compare my data to that of 10,000 other people who match my age and other characteristics and build a model that allows me to see how much my brain or my body activity differs from that group. And so I'm going to show you really quickly here. This is actually an example of what your kind of interactive reports look like. They're all nice HTML reports that show you all kinds of interesting features in your data. And I'm going to show you really quickly a very quick demo of what that might look like if you are doing this yourself. So I'm going to get my mouse out here. And I'm going to go. So here I am on, oops, I think I need to do something else, like stop the presentation. So that okay. So, all right. So here I'm in Neuroscale on my web dashboard, and I'm going here, and let's say that I just collected a bunch of data, and now and my data is with somebody who's been. This is actually data that we collected, and we're working with NASA, with crew members who are in habitats where they're being put in there for 2 weeks at a time, and we're trying to measure their brain performance, their cognitive performance over the course of those 2 weeks and see how their brain activity changes in different kinds of cognitive tasks, and then predict future cognitive performance so that NASA can help develop better kinds of interventions that would enable long-duration deep space exploration, hopefully the missions to Mars in the 2030s. And so this is an example where we're taking one of those subjects. Let's say I just collected my data set from that subject, and I want to know, combined with the other data I got from that subject, what's the quality of my data? Did I get good data? I want to know I want to run a statistical model that says, how did all of my activity, including the data that I just got right now, how did that change over the course of the last, say, 12 or 13 sessions that I've recorded? And I want to get immediately figures showing me insights into my neural features and bio features. So if I uploaded that data here, I have actually my data all organized right here. I just dragged and dropped and added those. Of course, I've done that before because we don't have time to go through this in great detail. But let's say I just added my new data set. So I say I'm going to create a new task here. And here I've added a couple pipelines. And this is a 1/n study analysis that allows me to basically run statistical modeling if I have a bunch of different sessions. So this could also be like you're brain stemming people over multiple sessions and you want to see how their brain activity changes and whether it's statistically significant. So here I'm just going to go ahead and I'm going to say I'm going to pull my data in And the folder here is going to be subject, and this is going to be my session. There's a little formatting that you can do to basically automatically parse all your data and build a statistical design. And I have options for pre-processing my data, for mapping brain sources inside the brain, for extracting features in the spectral domain, running statistical models. This I tell it what my study design is. And now I just go ahead and I say create task. And so now it will go and it'll spin up a task, and I go to my tasks and I say, okay, great. So now I've submitted a new job to Neuroscale that's now in about 15 minutes it will return my result. I don't have time because I'm out of time on this, or just about, but I'll show you what the result will look like. In 15 minutes, it's going to spit back out a report, as well as all my process data that has all of my insights and features and statistics and so on and so forth. So I'm just going to spin up this report right here, which is downloading relatively slowly. Okay, so I now have my report. And so here's my report. In 15 minutes, I can see right away what is the quality of my data. It's just loading the HTML. So I can see, what channels were good, what channels were bad, what's the probability of a channel being bad across my different sessions or that one session. I can look at various quality measures here. I can look at my power spectra, which is how different frequencies in the brain are changing over my different sessions, and I can see what statistical significance looks like and how those frequencies changed over different points in time. This is highly interactive, so I can go and I can see a lot of interesting data features as I move around through this. So here, for instance, we can see that there's a significant alpha effect in certain channels in the brain that changes over time over these sessions. So the person's brain is changing over these 12 sessions while they've been in this habitat. I can also look at something like here as a neural measure of sort of an analog of attention, beta divided by theta plus alpha. And so I can just zoom in and see that there's a significant trend where the beta activity is decreasing over time relative to these theta alpha modes. And so that may be an indication of changing cognitive performance. And if I look in the source domain, I can actually see a really strong effect here as well. And so just looking through all of that, I can see kind of interesting features, increase in theta and alpha activity, for instance, or the ratio of theta to alpha over time. This is showing how my activity is distributed over the brain. Connectivity maps showing how brain networks are changing over time. And finally, I can look at all my statistical modeling outputs and search for things, and I can see, oh yeah, there's statistically significant effect here in these neural features in channel P8. And so all of that within just a few minutes of having collected my data. And there's other designs and things we can do too, and if you're interested, I can show you other examples later, how you can do more complex designs. But that's just a little preview of that. I'm definitely out of time, so I will just go ahead here and say, if you're interested in this or other kinds of ways to accelerate your research and development deployment, come and contact us, and you can get started right away with NeuroPipe or with Neuroscale Insight. Thank you.